contents. You know these page numbers are not right. So help me out. What's the next page number? 84. This is page 84, and you're going to call it applications. Oh, well, okay then. Okay. This is just going to be on page, oh. You may sometimes think, why in the world would I ever need to be able to do a rational exponent? If you have money in the bank, the formulas that we're going to look at are why you might ever need to know how to do a rational exponent. All right. Ladies, gentlemen, let's get on it. Let's read what's in the box. Are we together here or no? Mathematical problems that include radical equations or radical exponents arise in a number of professions, from engineering to nursing. Oh. Let's take a look at some of the contexts within which radical equations arise and consider how to solve them. Okay, let's take a look at this one. Banking. The initial amount deposited in a savings account is $1,000. The amount A of dollars in the account after T years can be represented by this function. Now, it's hard for me to see, but I think that says A of T equals 1,000 times 2 to the T over 24. Now, I want you to notice, what does the A stand for? Yeah, it's how much money you have in the account after a certain amount of time. What does the T stand for? The number of years, right, time in years. To the nearest cent, what will the amount in the account be after 6 years? Okay, what do we do with 6? Plug it in for T, right. Okay, so we're going to do, and I want you to write this down on yours. I want you to write A of 6, because we're substituting 6 in for T. 1,000 times 2 to the, now Gavin, I think said it, if you put 6 over 24, would simplify to a fourth, right? All right, let's get your calculator. Now, where did mine go? Because I have it.
There we go.
1,000 times 2 raised to a, and I want you to do this, do alpha y equals 1/4. Can you get it in to make it look like that? Anybody having trouble making it look like this on your calculator? You should get this answer right here. Now, how do we round this number to the nearest penny? So we would say $1,189 and not 2 cents, not 2 cents, 21 cents, 21 cents. So on your paper, 1189.21, you will write a sentence and you will say, after 6 years,
the bank will not have enough money to run.
the account, okay, what am I doing? Will have I want you to write a sentence. You ready? Let's go to biology. What's wrong with biology? Everything. Okay. This is a biology formula. Kleber's law. The formula P equals, now let's read that real carefully, 73.3 times, what's that say? The fourth root of m cubed, yeah. Known as Kleber's law, relates the metabolism rate. You guys know what metabolism is, right? Yep. How fast your body processes food. In calories per day, and the body mass of an organism in kilograms. The table below shows the typical body mass of several members of the cat family. What is the metabolism rate of a cheetah to the nearest calorie per day? All right, so let's take a look at this. What does the P stand for? In the metabolism rate in calories per day. And the M stands for the mass in kilograms. So we've got a cheetah. Where does the 55 go? Does the 55 go for the P or the M? The M. So we've got P equals 73.3 times, now how in the world are we going to do this? The fourth root of 55 cubed? Let me ask you a question. How could we write this with a fraction exponent? 55 to the 3/4, right. So if you want to write it this way, that's fine. Or if you want to write it this way, that's fine. It doesn't matter. Those are the same thing.
Is that raised?
That is raised to the power of 3/4, yes. No, we got to do it. I'm going over here to pull my calculator up. $73.3 times. That answer? Okay. Anybody get that? Okay. 73.3 times. Did anybody want to do it with the fourth root? Do you remember how to do that? Type in your 4 and then go over here to math, option 5. 55 raised to the third power. This says to the nearest calorie per day. So what is this answer to the nearest calorie? 1,400? To the nearest calorie. So do we need tenths or hundredths or anything? No. So 1,480, period. 1,480. So the metabolism rate of a cheetah is 1,480 calories per day. That's what you're going to write. If I can get something to write with. Calories per day. Questions so far? Pretty easy? Look at B. Now B's going to use the same table. Estimate the mass of an animal with a metabolism rate of 1,500 calories a day. How do we do that? Guess. Well, P equals, let me write the formula down. P equals 73.3 times the fourth root of m cubed. Estimate the mass of an animal. Just stop right there. Estimate the mass of an animal. Am I looking for m or p? Yep. Which one of those variables stands for the mass? M. So I'm looking for m, right? I'm looking for m. The p stands for the calories. Yeah, why'd they put p for calories? I don't know. But p is the calories per day. So which of those variables do I know? I know the p, don't I? So what are we going to put in place of p? 1,500. So we're going to write 1,500 equals 73.3 times the fourth root of m cubed. How in the world do we solve that problem? Divide both sides by 73.3. Now, do not touch your calculator yet. 1,500 divided by 73.3 equals what? The fourth root of m cubed. Again, why don't we write that as m to a power? M to the 3/4. Now let's see what you can remember from a week before last, which I know has been a long time. Do you remember what we could do to get that m by itself? How could we get rid of that 3/4 power? Not times it by 4/3. What do I do with 4/3? Raise both sides to the power of 4/3. Right. So let's raise each side to the power of 4/3. This is what I want right here. Now you're probably thinking, that's just ugly. I know, but just give me a minute. What's the right side now? That's just m, isn't it? So doesn't that say m equals this crap right here? I want you to go to your calculator and we're going to put that in. Come on. It was 1,500 over 73.3. And we're raising that to the Did you get it to look like that? You getting that answer? Okay, so keep it on your computer. Keep it on your calculator. What in the world was the question? Estimate the mass of an animal with that metabolism rate. What are all of these mass? What the crap? What are? So what do we need to round to based on what these are done have done? To the nearest, to one place after the decimal, which is the tenths place. So take that number that you have on your calculator and round it to the tenths place. It would be 56, and we're going to say, do you see how these have 0.0? So let's write 156.0. So the animal's mass. What did I say?
You said 156.
Sorry, 50. My bad. This is mass, right? The mass of the animal. Mass of the animal is 56 kilograms. Doing okay? So far, so good. Physics. Physics. Anybody know what the nickname of the city of Denver, Colorado is? It's the Mile High City. Why? Because it's in Colorado? Well, no. Its elevation above sea level is 5,280 feet, which is a mile. That's why Olympians who like running, track, bicycles, anything that uses aerobic activity, that's why the Olympic Training Center is in Denver, because they will train at altitude, which makes it much easier when they are competing down at sea level. All right, air pressure decreases with altitude according to that formula. When you put this in your calculator, please make sure you put the right number of zeros in that exponent. 4 zeros after the decimal?
Yep.
Okay. Have mercy. I know. P is the air pressure in pounds per square inch, and A is the altitude in feet above sea level. Use that formula to estimate the air pressure. If we're estimating air pressure, are we looking for P or are we looking for A? We're estimating air pressure. P is the air pressure, so we're looking for P. And what does it tell us here? Colorado is 5,280 feet above sea level. Let's write our equation. 14.7 times 10 to the negative
0.0000014
times
5280.
Put it in your calculator just like that. That is a lot. Just be careful, you can do it. Let's see, 14.7 times 10 to the, mercy, negative 0.1234, 14 times 5,280. Is that put in right? Bless somebody. What's the question? Round your answer to the nearest hundredth. The second one past the decimal. 12.40. 12.40. Yep. So, come on, Stennett. Denver's air pressure is about, I already forgot what it was.
12.40.
Thank you, 12.40. My memory doesn't last very long. 12.40 what? Pounds per square inch. Ah, you knew the abbreviation. If you know the abbreviation for pounds per square inch, you can use it. Make sure you use your units. I cannot emphasize enough how important it is to use your units, okay? Use your units. Bless you. Bless you. Aviation. I want the people who are flying the plane I'm on to know what they're doing, right? Or at least the people who are on the ground telling them what to do to know what they're doing. Pilots use this function to approximate the distance in kilometers to the horizon from an altitude A in meters. All right. What is the approximate distance to the horizon observed by a pilot flying at an altitude of 11,000 meters? The first thing I always like to do is I got to figure out what in the world the variables mean. What's D? Distance in kilometers. What's A? In altitude in meters. Good. What are we trying to find? Distance to the horizon. So we are looking for D or A? We are looking for D. So we're trying to find D, right? All right. D of, what is A? Notice it says A is measured in meters. So is this 11,000 in meters? Yes, so we're going to have to use 11,000. So D of 11,000 is...
There's going to be ones that we have to like convert.
It's possible. That's why you'll need to watch your units. Times the square root of. That ought to be pretty easy, yes? Run to your calculator. Put it in. The distance to the horizon. Shush.
How are you supposed to finish it?
What do you mean, how are you supposed to finish it? It says approximate the distance in kilometers. So we're going to round to the nearest kilometer. So what is it? 373? Yep, I agree. Is about 373 kilometers. You can use abbreviations for your units, that's fine.
That's like... Oh, yeah? They like... Can't do that. They
If the distance to the horizon is about 550 kilometers, at what altitude would you expect the pilot to be flying? Which of the variables am I looking for if I know the distance to the horizon is 550 kilometers? I'm looking for the altitude. So what equation am I going to write down? Almost. Do I know D or do I know A in this question? I know D. Yep. Times the square root of... No, hang on. The square root of the altitude in meters, and I'm looking for altitude, right? Now, no calculator yet. Let's get A by itself before we put it in the calculator. Now, Gavin said divide by 3.56. That's right. That's right. Now we'll square both sides. And this is what you're going to put in your calculator. While they're figuring, I'm going to be writing. The altitude is about, we're going to the nearest meter. So the nearest meter. Okay, if you are getting a fraction as your answer, that's not a problem. Go to the button that says math on the far left. And option 2 has arrow decimal. Hit that option. And that'll change a fraction to a decimal. So 2.43. Huh?
I think.
What'd you get?
Okay, you're gonna say a little slower. 20.
Try that again.
3,868.
868.
Like 51.
Yes.
So 869.
Yes.
Is that meters? Anybody else get that? Okay, I'm gonna have you do the next one, and I think we're on, where are we, example 5? Cars. Well, I'll tell you what, I'll read through it with you, and then you'll do the problem without my help. All right. Listen, well, I don't want a crayon. If you want a highlighter, I got a black tub of them over there. So if you want a highlighter to highlight on these, you are welcome to get one. The speed S in miles per hour that a car is traveling when it goes into a skid. Do you know that police officers have these formulas? I'll tell you a story. All right, so the speed that a car is traveling when it goes into a skid can be estimated by this formula. Oh, we got 3 variables, don't we? Where F is the coefficient of friction. That has something to do with how the tires are against the street. I don't know exactly know. And D, let me get another color. And D is the length of the skid marks in feet. All right, so we know what we got here. After an accident, a driver claimed that he was going 45 miles an hour. The coefficient of friction under accident conditions was 0.7. Is the driver telling the truth about his speed if the skid marks were 120 feet? Maybe we need to work this one together, right?
Yes.
Is the driver telling the truth?
S equals the square root of 3 times 7 times.
Okay, so Gavin wants to find his speed, right? Gavin wants to find his speed, I agree. He claims he was going 45, but we're going to see for sure. So what have we got? S equals the square root of 30 times F is the coefficient of friction, 0.7, times D is 120. All right, run that on your calculator. So we know this guy was lying because this is about 50 miles an hour. So is the driver telling the truth? No, he was going 50 miles an hour. Law enforcement learns how to do this stuff. Now they will have it. They'll have a little program on their on their computer, but they know how to work with this stuff. All right, look at part B. If a car was traveling 58 miles an hour under the same conditions, what would you expect the length of his skid marks to be?
So you would go 58 equals the square root of 3 times 7 times 2.
The square root of, I'm listening to you, 30 times 0.7 times, was that D? How in the world do we do that?
Out of the first.
How do we undo the square root? Square, yeah, let's square both sides, I agree. What's 58 squared? Say it again.
Sorry, 3,000.
3364 equals 3364 equals 21D. What's D? Oops. What's D? I hear a 160. Do I hear anything else? Got another 160. Okay, I see 3 160s. Anybody else good? Anybody get anything different? What kind of sentence are you going to write? Yeah, the skid marks are 160 feet long. The skid marks are 160 feet long. We just have one more question. Construction. I don't use math in construction. Shoot. I want to build houses. I don't need math. All right. The diameter of a rope in inches. Would you hush? Yeah, I know you're talking to your homie. Yeah. The diameter of a rope in inches. The diameter of the rope. So like if you took a cross section, if you sliced the rope, if you had the rope laid down and then you sliced it. So here's my rope. What? Not in that. There's my rope. You slice it like this. Okay. The diameter is this right here. That's right. Radius is half the diameter. Good. All right. Needed to lift a weight of W tons is given by that formula. What's this? Where is it on your calculator? Do you see it on your calculator? If you don't see it, you make sure you find it because you need to use that key. Do not use 3.14 because that is not exact. How much weight can be lifted with a rope that has a diameter of 1.5 inches? 1.5 equals? See if I can get this moved around. 1.5 equals. Is pi under the square root? No. Yeah. You can't. I can, but what about this pi? By 2? I can, look, on the right side, now Gabe's already figured it out. On the right side, what's happening with that pi? How do you get rid of dividing by pi? You multiply by pi. So, let's multiply both sides by pi. Now, do not do that on your calculator yet. Not yet. Just hang on a minute. So this says 1.5 pi equals what?
Equals 15. Yeah.
Now what? I do what? Say it right. Now I square both sides, right? Because that square root's isolated. Now we're going to square both sides. No calculator yet. Oh, yeah. So this side's going to be 1.5 pi, and you're putting that in parentheses because you got to square the whole thing. Then you divide by 15, right? So W equals 1.5 pi squared divided by 15. Now, what's being squared? Is the 15 on the bottom being squared? No. Type it in your calculator. Manny, are you all right?
Sure. Oh, it's
1.5 pi squared, right? Divided by 15. Is that it? Is that it? I hope it is too, because if it's not, I don't know what is wrong. Now, look at the question. How much weight can be lifted? Now, it doesn't tell us how to round, so I'm just going to tell you. We're in tons. Let's round to the nearest hundredth.
1.48.
Hundredth, which place? 1.48, so we're going to say 1.48 tons. So we're going to say, well, let's come up with a sentence. Beautiful. 1.48 tons can be lifted with a rope having diameter of 1.5 inches. That's great. Or you can say the rope can lift a weight of 1.48 tons. Ladies and gentlemen, that's the end of this unit. Now what I'm going to do, I'm going to give you your assignment, but the thing is you cannot do this without a calculator. I mean, it's just impossible. So,
Check calculator out.
so you're going to have tomorrow in class to work on this as well.
Right.